All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video and then unpause the video when everyone has finished, and I will go over the correct answers. So on this one, you're going to do a remove, replace, reduce. So we're going to have x squared plus 8x plus 12. And then don't forget to replace your 3 in front of both of your x's. And so the numbers that multiply to give you a 12 and add to give you an 8 are 6 and 2. The first set will will divide by 3. So if you divide by 3, you'll have x plus 2, and then you'll have 3x plus 2. And so that's how it'll actually factor. For the polygon here, we want to know what the perimeter is. Well, they told us all except for this side here and this side here. This part is 15, so the rest of this is, this part is 5, so the rest of it is 15. And then this part here is 6, so that side there is 4. And if you add all of those up, you're going to get 60 for your perimeter. Moving on to the lesson, we are looking at lesson 72 today. We're dealing with one side plus 2 other parts, and then we're going to look at the law of sines. So hopefully you'll understand what it means whenever it says one side plus 2 other parts, and you'll also understand the law of sines. We did talk about the law of sines last year in geometry, so if it seems kind of familiar to you, that's where you've learned it. So if you have the length of one side and the measures of 2 other parts are known, it's possible to solve for the measures of the missing parts. So if you have a triangle here, and you know that this is a 4, and you have a side here, and a side here, then you can solve for the 3 angles. Or if you knew one of the sides and one of the angles, then you could solve for the other missing parts. Or if you knew 2 of the sides, 2 of the angles and none of the sides, you would still be able to solve for the missing parts. So as long as you have one side length and then 2 other parts, you're going to be able to solve for everything else in your triangle. We cannot solve for the missing parts if we don't know at least one of the sides. So if they don't tell you one of the side lengths, then there is no way to actually solve for all of the missing parts. And the reason for that, if you have to have 3 pieces of information to be able to solve for your triangles. And so if we only know the 3 angles here, we don't know what kind of side length we're going to have, because this triangle here could be that size, or it could be teeny tiny. We don't know how big our triangle would be if we only had the angles. So that's why you have to know at least one of your side lengths. Okay? If you have a right triangle, then all you need to know is the length of a side, and then either another angle or another side. Because if you have a right triangle and you know a side length, that's 2 pieces of information, then you can either add an angle or another side, and that'll give you the 3 pieces of information that you would need. So if you have a right triangle, you need a side length and then either another angle or another side. A triangle that is not a right triangle is called an oblique triangle. We talked about last year oblique solids. I'll draw an oblique cylinder for you. It's just one that's kind of tilted over. It's not a right cylinder, which is whenever it looks like this, and this is at a right angle. So a triangle that is not a right triangle is an oblique triangle, because instead of it having a right angle, it got tilted so that this angle here is no longer a right angle. An oblique triangle can be solved if you have one side and then 2 other parts. So again, you have to have a side length, and then the other 2 parts, it doesn't matter what they are. It can be angles or sides or a combination of the 2. So an angle and a side that is opposite that angle constitute a pair. So your angle and the side that is opposite it makes up a pair. The law of sines gives us relationships that involve the lengths of the sides and the sines of the paired angles. And I'm going to show you a picture. Angle A and side A are a pair. Angle B and side B are a pair. And angle C and side C are a pair. And so the law of sines is written below the triangle. We have A over sine A equals B over sine B equals C over sine C. That is the law of sines. And it gives you a relationship involving the lengths of the sides and the sines of its angle pair. So now let's look at an example when we use the law of sines. So it says to solve it for the unknown parts. So the first thing that you're going to want to do is to set up your ratios. So A, the side length that goes with A is 10 over the sine of angle A. And then we have X over the sine of angle B. And then we have 7 over the sine of 23. Now you have to put the sine of angle A, the sine of angle B, and the sine of 23. I've had people just do 10 over A, X over B, and 7 over 23, and that doesn't work. You have to actually do the sine of the angle. And so we're going to start by solving for A, because we can use the first to the last ratios that we have. So we'll have 7 sine of A equals 10 sine of 23. And then I can divide by 7. And that'll give me sine of A equals 10 sine of 23 over 7. And so if you get your calculator and plug 10 sine of 23 over 7, you should get 0.558, etc. And then to find A, we need to take the sine inverse of that. Now, don't just do the sine inverse of this number that you wrote down. You need to go and use the whole number that the calculator gave you. And so you should get 33.93 for your angle A. If you just do sine inverse of like the 0.56, let's say you had rounded it, you would have gotten 34.06 for your angle, which is close to what we have, but it's not the actual answer. So make sure that when you go to use your calculator, you actually use the whole number that the calculator gave you whenever you input that. So if this angle here is 33.93, that means that we can find angle B because our angles all add up to 180. So subtract your 23 and your 33.93. And that gives you that B equals 123.07 degrees. And so there would be our two angles, and now we just have to find X. Well, if we plug in what B is right here, 123.07, then we can use the second and the third ratio to solve for X. So I would have sine of 23 times X equals 7 sine of 123.07. And so you would just divide by the sine of 23. And if you plug that into your calculator, you should get that X equals 15.01. And it should be the longer side because it's opposite the larger angle. Okay, so that's how you would use law of sines. So again, hopefully that is kind of familiar because we did deal with it last year in geometry. Looking at this one, we want to solve this triangle for the unknown parts. So again, we're going to set up our ratios. 10 over the sine of A equals X over the sine of B equals 7 over the sine of 23. So now we're going to use the first and the last. We're going to have 7 sine of A equals 10 sine of 23. And we're going to divide by 7. And so you're going to get that the sine of A is 10 sine of 23 over 7. Which is 0.558. And so when you do sine inverse of that whole number that the calculator gave you, you get 33.93. Hold up. If you look at your picture, does that look like an acute angle there? Is A an acute angle? No. What other quadrant could this angle have been in? Instead of the first quadrant, it could be in the second quadrant, because remember, sine is positive in both. And so what we need to do is to find the second quadrant angle for this. So you would just say 180 minus that angle, 33.93, and you would get that your angle A is actually 146.07. And so that would be your angle for A. And the reason we knew that is because this angle here is an obtuse angle. So 33.93 clearly does not work for that picture. So if angle A is the 146.07, you can subtract it and 23 from 180, and you should get that B equals 10.93 degrees. And then if B is 10.93, we can use these two ratios here to solve for our x. And so we would have x sine of 23 equals 7 sine of 10.93. And you're going to divide by the sine of 23 to get what your x value is. And if you plug that into your calculator, you should get 3.40 for your x value. Okay, so I'm going to go back to this other picture real quick. The information they gave you was that an angle was 23 and your sides were 7 and 10. On this one, the information they gave you, your angle was 23 and your sides were 7 and 10. We ended up with 3 different answers, though, from the previous example because of the picture that they drew. So you need to make sure to look at the picture that they give you to know if your angles make sense or not. Now, they're not drawn 100% to scale, but if you have an acute angle, then your answer should be acute. If you have an obtuse angle, then your answer should be an obtuse angle value. Alrighty, so now let's look at another example. We want to solve this triangle for the unknown parts. Well, if you look at it, we can go ahead and find what A is because they give us 2 angles. So A equals 100 because your angles have to add up to 180. So now we just need to find what M and K are. So I'm going to say K over the sine of 100 equals 7 over the sine of 30 equals M over the sine of 50. And so we can use the first 2 ratios to solve for K. So out of K sine of 30 equals 7 sine of 100 and divide by sine of 30. And so your K should give you 13.79. And then if we use the second and third ratio to solve for M, we'd have M times sine of 30 equals 7 sine of 50. And then divide by the sine of 30. And if you plug that into your calculator, you should get 10.72. And so that's how you use the law of sines to solve for missing parts in a triangle. So hopefully that jogged your memory from last year and that you remember how to do it, and if not, you understand it now. So for your homework, make sure that you do that tonight, number 1 through 30, and then we'll go over any questions you have tomorrow.